Good morning. Today I am going to talk about mathematical logic. Mathematical logic is one of the units in discrete mathematics. Logic is basics of logical thinking or test of reasoning is known as logic. This logic was first studied by Greek philosopher Aristotle 388 to 320 BC. He is the first man who gave lot of rules and regulations for the logical statements. Another well-known author, Alice in Wonderland book written by Carl Lewis, he also given lot of logical arguments and statements in his book and gave a valid conclusion for those statements. So, logic is basis for computer science also. So, without logic, computer cannot be functional at all. In logic, we talk about basically two type of statements. Okay. One is called declarative statement, another one is called non-declarative statement. Any statement which says true or false as answer is called declarative statement. Otherwise, others are called non-declarative statement. For example, suppose I say today is Monday. Monday is a falsehood. So, it is a declarative statement. Suppose I say please bring the water, I ask you. This is not a declarative statement because this is only a command, or please open the door, it is also just a command. So, it is non-declarative statement. So, statements which give answer as true or false are declarative statement, others are called non-declarative statements. So, you can have some examples as I go on here. Chennai is a city is a declarative statement. Tamil Nadu is the capital of India, it is a non-declarative statement. It is declarative statement because it is falsehood. So, any statement which gives true or false are called declarative statements, others are called non-declarative statement. Okay. Then in logic we use only notation as alphabets. Alphabets with capital letters are called used for notations except T and F. T and F letters are assigned for true and F is assigned for false. These two letters are not used for any statements, for a symbolic form. Okay. Suppose I say Jack and Jill went up the hill, the famous word, isn't it? Jack if Jack went up the hill, I can say and Jill went up the hill as two separate statements. I can symbolize this statement as suppose say J1 stands for Jack went up the hill and say J2 for Jill went up the hill. Then I can say it is J1 and J2 as a symbolic form of this statement. So, in logic we use 5 types of connectives. Connectives means symbol that connects two statements called connective. Okay. As a preposition using in English, no, and, but, or like that. Such a way they are using connectives in logic also. In logic we have 5 basic connectives, namely negation, conjunction, disjunction, conditional and biconditional. Each one has some different symbols also. For negation we use some symbol as 7 like numbers to be put before the word. So, or using not word in the appropriate place of the sentence given, or you can add the phrase it is not the case that to the before the sentence given. Suppose for example, I say today is Monday. For this statement negation is today is not Monday one way, or else it is not the case that today is Monday also write one to make it a negation. So, negation is given a statement I can say negate of the statement is known as negation, and symbols as some tilde symbol or 7 like symbol will be putting on before the sentiment given. Another one is conjunction. Conjunction is combine two statements with a preposition and. Okay. Suppose P is one word and Q is another word. I can sentence this statement in connective and means P and Q. Okay. This is have truth value whenever P and Q are true, statement is true, otherwise it is false. So, note the point here, when I say a statement, the statement have truth value. Truth value stands for the statement can be true or false. This true or false is known as truth value of the given statement. Okay. Suppose I say P and Q is false means either P is false, Q should be false, then it is false. Okay. That's how the rules are framed like this. Okay, these are given by the Greek philosopher Aristotle, and this is the basis for our logical reasoning. Then if I say another connective disjunction, disjunction stands for P or Q like that. So, either P or Q, you can say the symbolic form P, some V symbol like that, and Q. What this says, P or Q is false whenever both P and Q are false, otherwise true. Okay, could you got the point here? Suppose P is false and Q is false, P or Q truth value is falsehood, otherwise it is true always. Suppose P is true or Q is false means this is true only. Okay. So, this may think to be remembered clearly. Conjunction gives both statements are true, it is true, otherwise it is false, and disjunction means P or of Q, it gives false when both are false, otherwise it is true always. Then another condition is called conditional connective. Conditional connective is connecting two statements with a if then prepositions as we use in English. Okay. If there is a flood, there will be if there is a heavy rain, there will be a flood. Usually using these words in English, no, isn't it? Something happened, this will follows. That is if then conditional statements. In that logic also, we take conditional statement like this: if P then Q. Similarly, put some symbol as some arrow symbol towards stating right hand side. Okay. If P then Q is a symbolic form of conditional statement, and this statement have when it becomes truth value is false means when P is true, Q is false, then P conditional Q is falsehood, otherwise always true. Note the point here, this should be all are accepted as it is, you cannot question how it is come. Okay, these are all accepted one and you have to take it as granted. These are all axioms you will see in mathematics. Axiom means this should be take it as granted and you should not ask any question about this truthness or validity of the statement is concerned. Then I have another connective is called biconditional. Biconditional means if both P and Q are same truth values, it is true only. Note the point here, if P is true, Q is true, then ultimate answer is true. Suppose P is false, Q is false, the P becomes Q is true. Note the point here. If either one is false means it is false falsehood. By symbolic we put some two caps between a straight line, symbol for biconditional connective. Okay. Now, using this basic connectives, we talk about logical reasoning now. So, given some set of statement, we call it as hypothesis. Hypothesis given as event accepted, and from that hypothesis we arrive at a conclusion. Okay. That is how we go check the logical reasoning. Suppose I say if there is a heavy rain, then there will be a flood. Answer statement say there is a heavy rain. From these statements we can conclude there is a flood. Yes, true, that is what the logic says. If there is heavy rain, then there will be flood. If there is another statement is there is a heavy rain, these two statements implies gives us a conclusion as there is a flood. Okay. This is called logical correct argument. And further, if we say in English we have some if then preposition, both have some connection. Okay. Suppose there is a flood, simply if there is heavy rain, there will be flood, we know that. But in logic, we do not need any connection at all for P and Q. Okay. If part is considered as antecedent and next comes then the statement is called consequent. Okay. Suppose I say if today is Monday, then 5 plus 2 equal to 7. If it is something idiotic, but it is correct in logic is concerned. Okay. Both can be any statement, discrete statement that can be connected by conditional statements. We can find only whether this given statement is true or false, it is a valid argument, is it true or not. That is the main thing in logic is concerned. Using these 5 connectives, we talk about what is loss of implications. Implications are valid statement from the given argument, these are all which false true. Okay. By loss of implications, we talk about first one is modus ponens. These names are all Greek words, so something sounds different. Modus ponens stands for given P contains Q, this 2 implies Q. Note the point here, P and Q implies Q. The other name is also there, that is law of detachment. Okay. Another statement is modus tollens. Modus tollens stands for negation of Q, P contains Q implies negation of P. Okay. Then disjunctive syllogism says negation P, P or Q implies Q. And another one hypothetical syllogism says P conditional Q, comma, Q conditional R implies P conditional R, and dilemma stands for P or Q, comma, P conditional R, comma, Q conditional R implies R. These are all accepted valid implications. Okay. Given these types, we can arrive as a given right hand side answers. Okay. This is all logically true one, logical truth one. Suppose I say as an argument take today is, if today is Monday, then tomorrow is Thursday. Today is Monday. Again, two statements. From these two, I can arrive at tomorrow is a Thursday. This is a true one. So, it is not any connection between these two statements. By logical what this law of implication says, according to that one, this answer is, this conclusion is a valid one. I told you one logical implication, hypothetical syllogism. What this says, P conditional Q, comma, Q conditional R implies P conditional R. This case, this implication can be applied this statement what I am going to tell now. If a man is a bachelor, he is unhappy. First statement. If a man is unhappy, he die young. Okay. So, by this statement, by combining what I get, if a man is a bachelor, he will die young. See, it is logically not truth one, but by a statement given, a man is bachelor, he is unhappy. If a man is unhappy, he is die young. Okay. From these two statements, I arrive at the conclusion that if a man is a bachelor, he will die young. So, this peculiar statement we can arrive at logically. Such things are to be verified by using these logical implications or logical equivalence. I talk about another thing, equivalence in next class. This I say more conditions to be applied to say whether condition given is valid truth or not. Okay, thank you.